Hi guys, welcome back to my channel. Once again, we're going to tackle University Physics with Modern Physics, Volume 1, 14th edition. This book is by Hugh D. Young and Roger A. Friedman. So we're going to tackle exercises and practice problems. So we're currently at chapter 11, which is entitled Equilibrium and Elasticity. So we will tackle, once again, we will tackle a total of 3 problems. For our first problem, problem number 1. A uniform rod is 2.20 meters long and has a mass 1.50 kilograms. A 2.20 kilogram clamp is attached to the rod. How far should the center of gravity of the clamp be from the left-hand end of the rod in order for the center of gravity of the composite object to be 1.30 meters from the left-hand end of the rod? So we're going to find the center of gravity of the clamp from the left-hand end of the rod. So we will use the formula for the center of gravity, which is for the uniform rod, which is x sub cm is equals to mass 1 times its center of gravity plus m sub 2 times its center of gravity sub 2 divided by the total mass. So we using this formula, we have to plug in the value. So 1.30 meters because it's the center of gravity. We want the center of gravity of the composite object to be 1.30 meters. So that is the center of gravity on the left-hand side of the equation. Then we equate that into 1.50 kilograms times 1.10. So why 1.10? Because we know that the center of gravity of a uniform rod is in the middle. So we have to divide 2.20 meters, which is the total length of the rod, by 2. So we get 1.10 meters. So 1.50 kilograms is the weight or the mass of the uniform rod. So plus 2.20 kilograms, which is the mass of the clamp. So our missing variable is the center of gravity of the clamp from the left-hand end. So we just leave that there, x sub 2. So divided by the total mass. So the mass of the rod plus the mass of the clamp. And so with a bit of algebra, we have to isolate x sub 2 so we can find the value. So we get x sub 2 is equals to 1.30 meters times the total mass of the clamp and the rod minus 1.50 kilograms times 1.10 meters divided by 2.20 kilograms. So inputting that in the calculator, we would get 1.44 meters. Okay, so we're done with the first problem, so we proceed to the next problem. Problem number 2. A specimen of oil having an initial volume of 590 centimeters cubed is subjected to a pressure increase of 4.0 times 10 raised to 6 pascals, and the volume is found to decrease by 0.47 centimeters cubed. What is the bulk modulus of the material? And what is the compressibility? So first, we would list down the given in the problem. So we have the volume of the oil, initial volume, which is 590 centimeters cubed, and the pressure increase is equals to 4.0 times 10 raised to 6 pascals, and the decrease of the volume is 0.43 centimeters cubed. So we're going to find the bulk modulus. So the formula for the bulk modulus is negative change in pressure times the initial volume divided by the change in volume. And we're also, we have to find the compressibility. So the formula for compressibility is 1 divided by the bulk modulus. So proceeding, let's first solve for the bulk modulus using the formula. So we plug in the values into the formula. So the change in pressure is 4.0 times 10 raised to 6 pascals multiplied by the initial volume, which is the initial volume of the oil, which is 590 centimeters cubed, divided by the change in volume, which is 0.47 centimeters cubed. So it's negative because it's a decrease in volume. So computing for that, we would get 5.0 times 10 raised to 9 pascals. So that is the value of our bulk modulus. So next, we will compute for compressibility. So again, the formula for compressibility is 1 divided by the bulk modulus. So we would just plug in the value of the bulk modulus that we have solved previously. So 1 divided by 5.02 times 10 raised to 9 pascals. And we would get 2.0 times 10 raised to negative 10 pascals raised to negative 1. So we're finished with the second problem. And for our last problem, a relaxed biceps muscle require a force of 25 newtons for an elongation of 3.0 centimeters. The same muscle under maximum tension requires a force of 500 newtons for the same elongation. Find Young's modulus for the muscle tissue under each of these conditions if the muscle is assumed to be a uniform cylinder with length 0.200 meters and cross-sectional area of 50.0 centimeters squared. So we have the force when the biceps muscle is relaxed, which is 25 newtons, and the length would be 0.200 meters because the biceps is assumed to be a uniform cylinder, so that is the length. So for the area, it would be 50 centimeters squared, but we would convert that into meters, so it would be 0.0050 meters squared. So for the length, we have change in length, we have 3.0 centimeters. So we also have to convert that into meters. So we would get 0.03 meters. And for the force that has maximum tension, it would be 500 newtons. So since we're computing for the Young's modulus, its formula would be the initial length times the force divided by area times the change in length. So we're computing for two factors here. First is when the biceps muscle is relaxed, and second is when it is at its maximum tension. So we have to find the Young's modulus for those two conditions. So we should compute for the relaxed force first. So for the Young's modulus for relaxed muscles or relaxed bicep muscle would be the change in the initial length, which is 0.200 meters. So that's the initial length times the force, which is when it is relaxed. So it would be 25 newton as given in the problem, divided by the area. So it is assumed to be a uniform cylinder. So it would be 0.0050 meters squared multiplied by the change in length when it is elongated, which is 0.03 meters as given in the problem, which is 3.0 centimeters. So plugging those values into the calculator, we would get Young's modulus pressure of 3.33 times 10 raised to 4 pascals. So that is for the relax or when the biceps muscles are relaxed. So next, when the biceps muscles is in maximum tension. So let's solve for the Young's modulus using the same formula. So its initial length is again 0.200 meters, and the force is different from the previous because its maximum tension force is 500 newtons divided by the same area because it's the same bicep and assumed to be uniform cylinder, which is 0.0050 meters squared times the change in length, which has a same value, which is 0.03 meters, and plugging in those values in the calculator, we would get 6.67 times 10 raised to 5 pascals. So those are the three problems for the University Physics with Modern Physics Volume 1 14th edition book. I hope this video helped you guys. Thank you so much for watching this video. I hope you learned a lot about equilibrium and elasticity. So thank you.